Welcome to Stay Sharp in Digital Engineering, your key to unlocking success in the digital evolution of products and manufacturing. Digital twins take center stage in this episode, with a few more planned to come. Jonathan and I unpack the world of digital twins, decoding the lingo from virtual twins to digital models, and why it matters. Kicking off this series, we start with step 1, understanding the importance of nailing down their purpose in your organization. Let's dive in. Welcome back, everybody, to Stay Sharp in Digital Engineering. I'm Juliann Grant. I'm one of your co-hosts with you today, and with me as well is Jonathan Scott.
Hey, everybody. Good to be back.
Yes, always good to be with you here, Jonathan. So today on our podcast, we are going to start off sort of an episode series around the concepts of the digital twin. Now, Jonathan's going to go into much more detail about this, but to frame it out, there are a lot of different terms that kind of cover the digital twin. And we've covered and we've actually had webinars on this in the past. And a lot of times people get hung up on what things mean and how to know what's going to be meaningful to their company as they're going to plan how to establish a digital twin or a digital thread in the organization. So this series of podcasts, starting today, we're just going to kind of cover the summary and level set on the terms, right, Jonathan?
Yeah, I think that's right. Let's talk about some terms, how we interpret them, what they mean to us, right? Not that we're the industry expert or standard on terminology, but at least, level set with everybody what we're thinking. And then get into, like you said, some of those concepts that make digital twins different or make it mean different things to different people, right? And I think that's a good place to get going for today. And then, as you said, for a series, I hope that what we can do is sort of go bit by bit, breaking it down, looking at the elements that help make up digital twins and how they might be different for different needs and that kind of thing. Because overall, I hope what we can do for folks is really explain more of the concept and get into it in a way that helps them think about their digital twin and maybe explain it to other folks in their business, maybe people who are less technical but are very interested in the content or the concept from a business perspective.
Right. Yeah. Our goal is to really make you smarter and help you bring these topics back to the people in your organization. So you'll have to let us know how we do. We definitely want your feedback. And if there are other terms as we're going through this that you think we should be talking about, please make sure I make a comment and let us know.
And bear with us.
Yeah, exactly.
It's an evolving area, right? And who knows how well these episodes might age. They might not age well at all. We'll see.
Among other things. So, all right. Well, let's get into it. So what's our first term we want to talk about, Jonathan?
Well, I think, we got to dig into digital twin. And then I think it's the one that's hardest because it's the umbrella term that everybody knows, right? So,
but it's also the thing everybody thinks they need, right? So
right.
How often do people come up to us at a show and say, I have to build a digital twin or something like that?
Exactly, right? And I think the reason we should spend a few minutes on terms is because that means different things to different people. Now, in my mind, what most people mean, like you said, when they come up to us at a show is, I need some kind of digital representation. And most of the time they mean of my product that will help me do business better, right? So I'm going to just put it in general terms. Sometimes they're thinking that it's going to help me understand my product better, and so maybe I could build a better product. Or sometimes I think they mean that it's going to help me manage my product better. So know what's going on with the physical one out in the field and help me react and have my business react better because I've got more information. I think sometimes they're talking about help me control my product out in the field, right? Like give it a system update or something like that. So I think digital twin, a lot of people, it's very generic. It means a lot of things to a lot of different people. And we ought to dig into some other terms that can, I'll say, clarify, remove the ambiguity of that. But I think that's what people are thinking about. I mean, from your perspective, is that what you feel like when folks ask us about it? That's what they're talking about?
Well, yes, but I also think the vendors talk about it and use a lot of
Mm,
other language to mean the same thing. And so, virtual twin is one of those ones that comes to mind as, you
yeah.
think, well, isn't that the same as a digital twin? Well, one would think that at the surface level, but at the reality, it's got its own life. So,
Well, let's talk about that one. Virtual twin is a good one. Um, the places I've heard it used, and again, I don't think anything that we're going to say on this episode or this series of episodes is comprehensive because we're not everywhere here in every conversation. But when I've heard people talk about virtual twin, I think they're talking about a digital twin prototype is another way I would describe it, right? So it is the digital representation of the future physical thing they hope to build, right? Where digital twin, I think a lot of times has the connotation of I've got a digital thing that matches a physical thing or aligns with a physical thing. And that's hence the twin concept. There's two of them. One's physical, one's virtual or digital, and they kind of match up. But this virtual twin concept is, wait, I don't have a physical thing at all yet. I'm still imagining it. So that's where I think calling it like a digital twin prototype is another good way of expressing this concept. I mean, that's what I hear. I think they're talking about really,
so does that,
yeah.
I'm sorry to interrupt. So does that get used as sort of the ideal target with the specs and all the information of what a twin should, ultimately look like? And as you're developing your twin model, you're developing up to this level, or
I
help
think
me
so.
understand that. Yeah.
Yeah, I think it is. I think it is serving as the ideal for the physical
Okay.
that you're going to make, right?
Okay.
It's meant to be, and I'll throw in another word that we should also, try and clarify from these, and it's serving as the model for the physical thing that you will make. Now, model, oh boy, there's a charged word, right? I mean,
Well, there are a lot of models in our business. So.
Exactly, right? In terms of all the models we talk about, right? So when I say the word model, a lot of people listening are probably just, I'll say at least for myself, immediately thinking 3D model, right? That's what I think of when I hear model. But let's put digital in front of it. Digital model, right? In the context of digital twin, I would say it's a lot like that virtual twin. It's a digital representation of something. Maybe there's a physical one that exists or not, right? With virtual twin, the concept is that it does not, a physical does not yet exist. But with digital model, let's say it is just the digital thing, and maybe it's a twin of a physical thing or not, but it is. It's not analog, it's ones and zeros, and it represents something else. We should stop there, right? That's enough to not get ourselves in trouble. But I think it's a useful term in the vocabulary, right?
Sure. Well, the question that comes to mind is there an in-between? No, there must be an in-between in this digital world of this model where, when you're making a part and you pull the digital data off of it and it doesn't quite match up to the perfect version of it.
Yeah.
Right? So in those cases, there must be a, obviously some quality review and some things that happen to help make that twin, that instance of that digital twin, to get it to the next level of the perfect virtual twin. And maybe I'm getting it wrong, but to me, there just seems to be like a little bit of a gray area in there.
I think it's an important point to talk about, right? And that's why digital twins, one of the reasons why digital twins exist and why they're important. And I'm going to throw a term at that. When you've got real world data from the physical instance,
right,
and you want to bring that back into the digital world, because like you said, it's sort of a gray area. If you've just got this virtual twin that's the ideal, but then you got the physical thing that really isn't quite like that. It's close, but a few things are different. How do you rationalize that? What do you do about that?
Right.
And I think the term I'll throw out there is digital shadow, right?
Yeah.
And so this gets into how does the digital model and the physical instance, if there's some kind of digital twin concept going around, the digital model that's just a representation and the physical instance that it's thing, how do you communicate between the two? And so if, like you're describing, you take some measurements off of the physical and you use that to I don't want to say enhance, but maybe that's the right word, somehow make the digital model more accurate, more representative, a better representation of the physical. That I think a lot of people would call a digital shadow. So moving data, and maybe they would say this is if you automatically do it, but moving data from the physical world to the digital world, that's a digital shadow. So a kind or a style, a type of digital twin, maybe.
Okay.
So that begs a bigger question though, right? I mentioned one direction. What do you call it when it goes the other direction, right?
Yeah, right. And what do you call it?
That's a great question. So if you have a digital model that can control your physical instance, I'm not sure if I know exactly the right term for that. Maybe I've heard somebody use the term digital surrogate, right? That your digital thing is, controlling or managing or something, your physical thing. So it's a surrogate for it. I don't know if that's the term that people use today, but let's smash the two together because this is where I hear people connecting that umbrella term to this specific case. I think when you have the case that data is flowing from the physical instance back to the digital model, and the digital model is being used somehow to control the physical instance, so you have some kind of closed loop.
Right.
That's where I think people say, yes, that's a true twin. That is really a digital twin. Was that right or not? I don't know, right? But that's what I hear people talking about.
Is it just an instance of that twin? Or is it,
now we get into another fun one, right? Okay, so to your point, when you bring up instance, here's what I think when I hear instance. If you've got a collection of products, right? You probably don't make one product. You probably make a whole family of them. And let's say we're talking about aircraft, right? We've got tail number 1, tail number 2, tail number 3, tail number 4. They're each unique instances of that aircraft. But they're all, Airbus A320s or Boeing 737s or whatever they are, right? They're all built off of the same digital model. And maybe aircraft are a bad example because every one is a little bit unique. But let's say they are. Let's say tail number 1 through 4 are the same. Well, each of those unique tail numbers is an instance. But now all these concepts we talked about with digital shadow, digital surrogate, digital twin, what does that mean? Because if you've got one digital model of that sort of family of aircraft, but you've got 4 unique instances, well, now what are we doing? What do we want to do? What do we intend to do, right? And this is something maybe we need to dig into in one of our more detailed episodes. But I'll say, I think there's a difference between a digital twin aggregate, right, and a digital twin instance. I think if you're trying to do that controlling thing we mentioned earlier, right, with a digital surrogate, you probably have to have a one-to-one, right? But if you're trying to do the digital shadow concept, then maybe you want one-to-one. You want, a digital model for every tail number, or maybe you want some kind of digital twin aggregate, which is, tail number 1 is about this big, and tail number 2 is a little bit different in size, or tail number 3 is a little different, and you average them, or you take the min and the max, but somehow you aggregate that information to represent that as a twin. But it's an important concept, a thing to think about, right?
Well, and my head goes to, the purpose isn't really to have this perfect instance of, or the digital, have all the digital readouts. It's really about getting the feedback of when a digital, one of the specs, if you will, or hey, this piece of the tail is bent. Somebody better pay attention, and that's going to get fed back to some other corrective process. I mean, to me, that's the whole point of having these digital twins, is to get some regular feedback on a product in use, so that way you can at least make sure you prevent problems, right? So that whole preventive maintenance thing. But but maybe I'm overlooking the whole point of just having the twin in and of itself. So
that's a great question, and I think that's something worth digging into. Now and in this series is, what's the purpose, right? What's the purpose of whatever kind of digital twin you need? Whether you need one type or another, and aggregate or instance-based or whatever it is, why are you doing it? Because that drives a lot and answers a lot of questions for you about how you build it, what elements you need to build it, that kind of thing. And I think you're right. Some cases, it is about maybe improving the performance of the product out in the field. Some cases it's about, preventing a performance problem, preventing breakage, that kind of thing. Other cases, maybe it's about improving the next version. Oh, I want to know how it's getting used so I can design a better one next time. But the whole control concept means it could be for a totally different purpose, right? It's about doing something to the product, having the product behave in a certain way, and that's got lots of interesting implications, scary ones too, right? Like, so somebody, you bought a product, right? You think it's yours, but somebody else is controlling it. I don't know, maybe you want that, right? Maybe you bought the product for that reason because you do want somebody else to control it or manage it. Maybe you didn't. I don't know. But there's a lot to that. And what you're asking, though, is the key piece. What's the purpose that you're building out some kind of digital twin? Because that'll really tell you what you need to do with it.
Yeah, that's a really good point. The other part that also my brain goes to is there must be a way to model the processes that go into building these products, right? So there must be some level of process replication or, process twinning, if you will.
Well, let's talk about those terms, right? Process is a great one. And then come back and connect it to that point about digital shadow and getting information, getting real information about the product that you thought you built. But let's start there with process. Is there a process twin? Because I think it's sort of implied. Everything we were just talking about digital twin was sort of about a product digital twin, right? A twin of the physical thing you create.
Right.
But your point is well made. You could also create a twin of a process, right? Think of something like, I'll say some manufacturing process like heat treatment or chemical treatment. People who are involved in those know that there are a lot of parameters that you control to get a certain outcome, right? And this is where the process and the product are connected. All right, I got some piece of metal I'm going to use on an aircraft somewhere, and it needs to have a certain hardness or a certain life. And we've learned over time through engineering and industrial processes, well, if you soak it in this chemical bath for this long, and then you put it under this heat, and then you dry it out with this humidity, and then you do this, and then you do that, and all of these have a certain time and chemical composition and what is it and the humidity and all these parameters, then you get the part that you want. And if you make a mistake and you do it for too short or you do it at too high a temperature or whatever, you know what? It's not necessarily scrap, but it's going to have some different properties. It'll behave differently in the aircraft later. So this is, I guess I'm getting into the why behind a process twin, but that's the idea. If you could create a twin of your process to say include all these parameters, then you could predict what's the outcome on the product that you're making, right? So your point is a good one. Process twins are a thing. They may have their more value to certain people than others. So if you just care about the product that's the output, maybe you want a twin of that. But if you care about reliably making that product, maybe a process twin is what you're more interested in.
Yeah, there's so many angles to it. It's and then I can't imagine how much data is required or gets generated in doing any one of these processes, right? Yeah. And then if you're talking about, you have multiple tails, multiple, airplane wings or whatever it is. You have multiple parts, you have multiple things, and then you have multiple parts within a product. The amount of data is mind-boggling. And so, where and who manages all this data? Yeah.
Well, it all stacks up fast. To your point, you can think it's a little bit mind-boggling when you think about one component. And then you think about 20,000, 50,000, hundreds of thousands of components going into an aircraft, right?
Exactly.
Wow, what a bunch of data. What do you do with it all? And I think it's an important point. I'm going to jump to another topic that I think is critical. And this is all good, I think, level setting to get into this. And that is fidelity, right? So with this whole idea of creating some kind of digital representation of a physical thing, we all know the real world is super complicated. So we've created, as human beings, we've created models of it. I mean, that's what science is, right? It's a model of our world to help us understand it. And that's really what we're talking about with these digital twins, is making more and more accurate, more and more detailed models of the real world. So that level of data, you may have too much data. You may have more data than you need to model something to the level that you care about. I think it comes back to that question of what do you care about? What's the purpose? Yeah. What's the purpose? So I think you have to make some choices, and in some cases, maybe trade-offs between what you can collect, what you can know, and what you need to know, what you want to get the output that you need. Hey, if I'm controlling the car, maybe I just need to give it the angle of the steering wheel. I don't need to give it the exact pressure of all the tires, and I don't need to tell it what engine RPMs to run at, and I don't need to tell it the fuel mixture. Maybe you can control all those things, but that's not important to what you're trying to accomplish.
Right. And getting back to that process twin, so I imagine if you multiply that by 100, you could really try to model a whole factory, right, before you try to build it.
That's a great way to connect those dots when we were talking about the process leading to oftentimes an output that is the product or a component of the product. When you start building that up, right, you could have a digital twin of a factory, right? So this is a little bit of a blend of those two concepts. If you've got a factory making an airplane, right, you could have multiple process digital twins of all the activities and operations and things you do. You could have a product digital twin of the various components that you're making, as well as of the end product, the aircraft. But you could also have, is it maybe some kind of hybrid digital twin of the factory itself, modeling the processes and the products coming out of it as that entire system. So at some point you get the point of diminishing returns on trying to give everything a label. But that concept of a factory digital twin, I think probably relates to what a lot of people are hoping, a lot of businesses are hoping they can get to. If I can understand all of my operations and everything I do to create my product, I can create products quicker, more efficiently, more reliably, that kind of thing.
Well, just the visibility alone and knowing and being able to monitor the process at that kind of level and then make efficiency changes that, are pinpoint precise, or, you kind of quickly, you want to stop making scrap, you want to reduce, your costs, so anything like that, you could start really getting, and it is in the weeds, but you could, obviously use some systems to help manage and monitor that at a level that makes most sense for you.
And that's what we keep coming back to it. And I hope, people don't get tired of us saying it, but it always comes back to that purpose. What do you need? What are you trying to accomplish that's going to dictate a lot of what you do? And in the other episodes that we'll get to, I hope we spend some time talking about those elements and how they connect to that, how they connect back to what people are trying to do and why you might need a certain element or not need a certain element based on what you're trying to accomplish.
Well, let's talk a little bit about the elements, if you don't mind breaking that apart a little bit. What kinds of things should we be should people be thinking about that they could extract from a digital twin?
Yeah, one of
the variables, or
and those are a couple different questions in there, and let's just let's give them a little bit of a touch here in this intro episode, and dig into them more later.
It's probably a whole episode.
or more.
Right.
So a couple of things. What are the things that people can expect or get out of it? Let's talk about that, and just maybe use some examples. I think industries care about different things, and I'm going to make some generalizations to make this point. So, if you're in one of these industries, forgive me if it doesn't feel like that matches what you do. But like the lifespan of a product could have a lot of influence on what kind of digital twin you might be interested in making. So if you're making something like a mobile phone, where the lifespan is arguably 2 or 3 years, maybe up to 5 or 10.
For the holdouts, yep.
Right. right? For the holdouts or the resale market or whatever.
Or whatever.
But, at some point, 10 years on, guess what? It doesn't work on the cellular network anymore, that kind of thing. But let's call it a lifespan of 10 years. That is a different animal in terms of what kind of digital twin you make, how you make it, how it needs to be maintained over time, compared with an aircraft, right? And so I'll say these days, I think, it's funny, back when I started in this industry, people would use 30 years as the example for aircraft. I think these days they're using 50 years as the example. Most aircraft, you need to expect a lifespan of 50 years, maybe longer. Okay, that's kind of a different animal, right? And it drives some different things in terms of how do you represent the data? What kind of models do you make? What kind of computing resources can you expect you're going to use to create and use these models over 50 years? That's hard, right? I mean, you ask folks in the aerospace industry about LOTAR, long-term archiving and retrieval, and it is a hard problem. And particularly when you look at what did people expect 50 years ago that their digital models could do for them, and what do they expect today? So when we think today, a digital twin should be able to do blah, blah, blah for me. 50 years from now, what does that even look like? What does that even mean? I don't know. It's hard. So that's just one snapshot of a characteristic between two different industries where you could see something very different. Let me give you another one. Hardware and software balance. Some products are mostly hardware. Some products are mostly software. Some are a good mix.
Good mix.
Right? But in terms of what does your digital twin look like, and knowing that the life cycle of software is so much faster than it is for hardware, what does that mean to a digital twin, right? What does that mean when programming languages changes,
Right.
So anyway, we could get deeper and deeper and deeper on
and
that, but that's just
AI
one.
layover,
Yeah, exactly.
Yes.
So that's one part of your question. I think the other piece you asked about is, what are these elements that we're talking about that we should get into in future episodes? Yes. And I don't think we know exactly where this road is going to take us, right? I've got some thoughts about what we could get into. But let me just give a couple of examples of what I mean that I think we want to talk about. One element that's important to a digital twin, it's probably the first one that people think about, is some kind of data management that's probably around product data management. At least that's going to matter to people wanting to make a product digital twin or a product digital model. And so, let's get into that. Let's talk about what you need in that, why it matters, why there are some PDMs that aren't going to support a digital twin, that kind of thing. Another element would be simulation data management. So, all right, let's say you've got the digital models themselves of the components, but we know a lot of the value we're talking about here could be predicting the performance of your product, right? Saying, hey, when I put it in the real world and it operates in 120 degrees Fahrenheit, is it going to behave the same way as what I designed it for? And, when the parts expand and when they, have fatigue and all these things. Okay, well, what's going to help tell you that? Simulation, right? Simulation is going to help you predict what might happen. That's one way. There are other ways, right? When we get into big data and collecting information back from the physical world, we could get some analytics that might help us. But let's just focus on simulation for a minute. That's an element. How does that fit? What kind of simulation do you need? And how does it connect back to that product data management piece we talked about? Okay, here's another one. IoT. I talked about getting data back, right?
Sure.
And analytics.
Yep.
So what is, and IoT is Internet of Things for those who haven't heard that before. The idea is getting data back from sensors on something in the real world, like the outside temperature. I used 120 degrees Fahrenheit as a thing. Why would I know to check for how my product's going to behave in 120 degrees Fahrenheit? Well, I would know because the sensor data told me that most of the time, that's the temperature range my product's operating in. Oh, that could be a really big deal if I designed it for 60 degrees Fahrenheit and it's operating in a different environment. So IoT might be a big deal in your digital twin for that kind of reason. But I think these are the kinds of things we want to get into in these other episodes, right?
Yes. Exactly. Yeah, I mean, that example kind of brings me back to what we talked about in the beginning about that gray area and what are you trying to do with the twin? Are you trying to do predictive maintenance or are you trying to innovate? And so really, the whole wearing of sensors is, thought to be around helping with that predictive maintenance piece. But, when you think about even consumer products and there's sensors and everything now. So
Yeah.
the purposes of all this is can be overwhelming, and I think really does come down to your business needs and what you're trying to accomplish and what data you really need to make your processes or your end products better.
Well, and let's
So,
draw a bright line under that point,
okay,
right? And that is a lot of people recognize the changing consumer today, the changing market, where people are, by industry, it's different, but starting to be comfortable with, I don't own the product, I use the service, right? Uber is
correct.
the example everybody uses, right? I don't own the car, I just use the mobility service. Well, so many industries are thinking about that as, well, maybe that's a more profitable model. Maybe it's a more sustainable model. For whatever reason, it might be better and they might be interested in doing it, but it tells you something about the value of this digital twin concept. And I'll just give you a theoretical example. If I'm somebody who sells, a go-kart, right? I could sell the go-kart or I could sell the fun that somebody has with the go-kart. If I'm going to sell the service of using my go-kart to maximize my return on investment in making the thing, I need to make sure that go-kart's running as often as possible, which means I need to monitor it. It means I need to maintain it. It means I need to do lots of things with it that mean I need more information. And this is how it connects to digital twin. So if a company is out there or an organization is out there thinking about, we might need to shift in how we approach the market to delivering a service or even an experience that's added onto a service or a collection of services that make an experience. If you're thinking about that and how you're going to get from where you are today selling a product to that, hopefully this series is very useful, right? Because there's a lot of reasons to have a digital twin to help get you there. So that's the bright line I would draw under what you were saying about you really got to think about the purpose.
And I think that's a good way to possibly close out this episode, because I think that we could go into a whole lot more detail and chew up another 30 minutes in no time. So
no doubt.
And
That's why we should take it by chunks, right? Let's do that. Let's shake it by chunks about what is important. So look out for the other episodes on this, about what are the important pieces or elements, contributors, etc., to a digital twin that could help you get you where you want to go. That's what I think we're hoping to get to here.
Exactly. Yeah. So we hoped that this conversation started to open your mind, especially if you are in the very early stages of looking at what you're going to do with the digital twin in your business and how it's going to best serve your organization. And then stay tuned, as Jonathan said, for some future topics. Great. Well, thanks so much, Jonathan. It's always a pleasure and fun to dive into some of these concepts. And
this one is
Jonathan
fun.
said, bear with us because we're not going to have all the answers, and we would love to hear from you if you have some concepts or things you want to contribute or have a unique idea to bring to the table for one of our future podcasts. Please let us know. We'd love to have that conversation. So with that, I think we're going to close out our episode. And thanks, everybody. And if you like this podcast, please give us a like. We'd really appreciate it. And subscribe on one of your favorite platforms or our YouTube channel. So with that, everybody, just stay sharp. Thank you.
Thanks, Juliann.
Thanks for being here and listening to this episode of Stay Sharp in Digital Engineering with Razorleaf. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your podcast platform or on our YouTube channel. If you have any questions or want to add to this conversation, please leave us a comment or send us an email to podcast@razorleaf.com. Until next time, everybody, stay sharp.